Our lesson today is on inequalities and solving inequalities. This will also be a review for you guys. We covered this in Foundations of Math 1. I want to make sure that you really, truly understand what an inequality is and what those solutions mean. Before we get started, I want to make sure you guys are in a quiet area, free from distraction as much as possible. Go ahead and get your pencil and paper out and ready to take notes. Make sure you're in a positive state of mind so you come into this lesson wanting to learn and remember what we're going to go over today. Our lesson objective is I can solve an inequality and graph the solution on a number line. As you guys will recall, we have several different symbols when we're looking at inequalities. We have a less than symbol, meaning fewer. Greater than symbol, which means greater than, more than, or exceeds, right? Less than or equal to, which means there's no more than that, or at most. So it means that number is included. Greater than or equal to means our solutions are greater than or equal to whatever number we find. This should all be reviewed for you guys. As you may recall, we graph inequalities on a number line in this class, and so we want to recognize the difference between less than or equal to, greater than or equal to, and just greater than or less than symbols. So we do that by graphing them just a little bit differently. When we are looking at just greater than or less than symbols, we graph the solutions with an open circle. Okay? So this particular example would represent x being less than 4. Okay? Our solutions would be everything less than 4. Over here on the right, we see that we graph greater than or equal to and less than or equal to with closed circles. That is intended to let us know that the number is inclusive. It is included in the solution. For example, we graph with the closed circle, so this would indicate x to be less than or equal to about 0.5 or 1/2. So everything less than or equal to a half would be included in the solution, meaning 0.5 will also make that inequality true. So remember these differences when we start graphing and looking at examples. Let's talk about what each of these different types of solutions mean. So if we solve an inequality, or we're given a solution for inequality and they ask us to graph it or interpret the meaning of it, there's different meanings to each of these. So let's first look at x is equal to 6. This means that our only solution, the only solution that works for the inequality would be 6. There's no other numbers. That is the only number that works. And this would be something you would find when we're just solving an equation, not an inequality. So that is more of an equation because we have that equal sign. This second one here has a less than symbol, which means we are looking at an inequality. And this tells us our solution to the inequality is all numbers that are less than 6. So we don't just have one solution. Any number that's less than 6 would make that inequality true. This third one here, it tells us x is less than or equal to 6. So our solutions here for this inequality would be all numbers that are 6, because 6 is included, and less than 6. So make sure you really understand the meaning of these symbols. So if we look at, we focused on less than and less than and equal to on this slide. Let's look at greater than. Same difference, right? This first one here would be an equation, not an inequality, because it has the equal sign. But this means there's only one solution, right? There's only one solution to this equation that makes it true, and that would be 4. If we look at the one in the middle, it tells us x is greater than 4, which means our solutions are all numbers greater than 4. So the solutions would include 5, 6, 7, 8, 9, 10, and so on. All the numbers that are greater than 4. Well, this third one here tells us x is greater than or equal to 4, meaning our solutions, because we have more than one, are the number 4 and everything greater than that. So 4 also satisfies that inequality. Let's look at an example. So we want to decide what makes solving inequalities different than solving equations. Well, one, there's a huge difference. Equations have what? They have an equal sign, whereas inequalities have comparison symbols, less than, greater than, less than or equal to, or greater than or equal to, right? That's the biggest difference. Equation usually has no solution, or they can have many solutions, but a lot of times we see equations that have one solution, right? And we expect inequalities to have more than one solution that work for them, because we have a symbol that tells us we're going to have many solutions, more than one. So when we are solving for inequalities, we do much like we would for an equation. We use inverse operations to solve for the variable. In this case, our variable is x, and we have a 5 plus 5 that's attached and a negative 3 that is attached, okay? So we want to get rid of those things first. The inverse operation of addition is subtraction. So I'm going to subtract 5 from both sides. Remember, we need to keep this equation balanced, because if we do not do that, we will not get the correct solution. So make sure if you do it to one side, you do it to the other. Now, we're going to continue to use inverse operations, but we do something a little different when it comes to multiplying by a negative or dividing by a negative. In this case, our negative 3 is multiplied with x. The inverse operation for multiplication is division. So we're going to divide both sides by negative 3. But when we do that, that negative tells us to flip our sign. So instead of it saying less than or equal to, it's now going to be greater than or equal to, because we are changing signs when we divide by the negative. So we get x is greater than or equal to positive 7. Now remember, you have to flip the sign of an inequality when you multiply or divide by a negative number. Don't forget to do that, or you will not get the correct solution. okay? Because that sign tells us what our solutions are going to be, if they're going to be greater than or equal to or less than or equal to. And you can always check yourself to see if it makes sense. So if our solution is all numbers greater than or equal to 7, I'm going to choose a number, for instance, that's greater than 7, or I can choose 7 itself to plug into this equation and see if it works. So I'm going to let x be equal to 7, since we know that that should also work for 7. And I'm going to plug it into our original equation. Okay, we get negative 21 plus 5 is less than or equal to negative 16. And we get a negative 16 is less than or equal to negative 16. That is correct. Negative 16 is less than or equal to, because it's equal to negative 16. If you were to choose numbers 8, 9, 10, and so on, that would also remain true. Whatever numbers on this side, the left side would be less than or equal to the number on the right side. When we are solving for inequalities, we don't just stop at the solution. X is greater than or equal to 7, right? We've got our solution, but now we need to graph our solution. So I'm going to use a number line, and I'm going to just number these like so. Okay? And if you recall, when we graph inequalities, let's go back. When we graph inequalities, we're either going to use a closed circle or an open circle. Our solution here is x is greater than or equal to 7. So that tells me that we're going to need a closed circle, because we have that greater than or equal to symbol, to graph this solution. So let's go back. We know we're going to have a closed circle. So what I'm going to do is find 7 on the number line. There's 7, and I'm going to put a closed circle where that 7 is. Now, our solutions are numbers greater than or equal to that. So my arrow is going to point this way. And if you notice, it's to the whichever way our mouth is opened, our arrow should go the opposite way. Hope that doesn't confuse you. But you can see, though, that this is true. This is telling us that all solutions 7 or greater work for x in this inequality. Let's look at another example. 167 is less than 6 plus 7 times 2 minus 7r. Again, this is a lot like solving for equations. We need to distribute this 7 first, because we need to be able to simplify in order to solve for r. So we get 167 is less than 6 plus 14 minus 49r. We want to then combine like terms. Remember, we want the simplest form. So we get 167 is less than 20 minus 49r. Well, this looks a lot like the previous example now, because we've got it to the simplest form. We want to use inverse operations to get these numbers away from r, to isolate r and get it all by itself. The inverse operation for a positive 20 is a minus 20. So the first thing I'm going to do is subtract 20 from both sides. Again, now we have a negative 49 times r. Well, the inverse operation of multiplication is division, so we're going to divide both sides by r, but because this is a negative number, we've got to switch the sign. So I'm going to come over here to the side because I'm running out of room. I know my sign needs to go the opposite way now. On the right side, I'm just left with r. On the left side, I am left with a negative 3. So our solutions is negative 3 is greater than r, or you could rewrite it for the variable to be on the left side. r is less than -3. And you can always check yourself. So let's pick a number less than -3. A number less than -3 would be -4. -4 is smaller than -4, so I'm going to let, -4 is smaller than -3, so I'm going to let x equal -4, and I'm going to plug it into our equation. I'm going to actually use the version where we've already simplified. So I'm going to go here. We've already distributed and everything, so I'm going to go and use that so I don't have to redo all the distribution and combining like terms and all of that. So now, let's see, what is 20 minus 49 times, so we get 20 minus 196, get 167, sorry, that should be positive. I don't know why I put negative. Anyway, we get 167 is less than 216. That is true. 167 is less than 216. So that is our solution. That does work. So remember, when we find our solution, now we need to graph it. Well, we've got r is less than -3. So I'm going to plot some numbers up here. -1, -2. And so on. Remember, if it doesn't have a greater than or equal to symbol, this one does not, it's not inclusive, so our graph is going to be with an open circle. So I find -3 and I put an open circle there. And I want my arrow, my tail, to point to all numbers that are less than -3. So this is what our graph would then look like. Let me know if you guys have any questions.